Hello everyone. In this presentation, I'm going to be discussing how to find fake accounts and social networks through analyzing their structure. The growth of online social networks such as Facebook, Twitter, YouTube has completely changed the way we interact in today's world, and these sites have shown tremendous growth in part due to how easy it is to register on the platforms and the vast amount of info that is available on these sites. For example, Facebook, which has 1.3 billion users, spend over 640 million minutes each month. That's over 1,000 years. Sybil attacks are an attack by malicious users who try to undermine the reputation system of a network. It is actually named after the subject of the book Sybil, which is a case study of a woman diagnosed with dissociative identity disorder. Now, Sybil attacks generally refer to peer-to-peer networks. However, a lot of other social networks are struggling with fake users undermining their networks and wreaking havoc on their users. Here are some examples of the danger of Sybil attacks. Stealing sensitive private information is a huge one. These fake accounts can be used to impersonate people and then potentially friend you on Facebook or any other social media platform, get access to your address, name, pictures of you, and all your social media posts. Trolling is another big one. It's very common on internet forums where people essentially are able to hide behind fake identities. Um, and I'm sure everyone's encountered trolling at some point in their time on the internet. Rigging popularity is another big issue. These fake accounts can either give follows or a fake popularity to like a single, either another fake account or even a actual like real account, and make them seem way more popular than they actually are. I think I saw a statistic where you could buy 1,000 Twitter followers for $14, which just shows how many fake accounts can be created on these social networks. And then breaking trust kind of ties off the rigging of popularity, where in peer-to-peer networks, a edge represents a trust relationship or a vote, and the nodes with the most trust or votes are able to access more of the network's resources. However, with the fake accounts, they're able to create a lot of edges and outvote the honest users, which breaks the trust system that's in place on the peer-to-peer network. Now, this begs the question of how does one identify users who are who they say they are, and whose activities can be considered genuine in a social network? Now, there are four main types of Sybil attack defense solution and schemes. The first one are graph-based schemes. And now graph-based schemes use social network information in the case of Sybil to represent interdependencies between two nodes or people using edges. And these graph-based methods strongly rely on social graph properties, thus the name. And they're able to use these properties to distinguish Sybil users from legitimate users. And these graph-based methods can be divided into two categories, which are Sybil detection and Sybil tolerance. Now, the graph-based methods are what we'll be focusing on in the later slides because they involve more analysis of the social network structure compared to the other methods. And I'll go over the graph-based schemes in more detail in the following slides. Now, the second Sybil attack defense scheme is machine learning based schemes. Now, machine learning is a technique used for autonomously acquiring and integrating knowledge obtained from analytical observations, experience, pattern recognition, and this scheme is usually divided into two main types. We have supervised learning and unsupervised learning. Now, supervised learning includes uses such as regression models, decision tree models, whereas unsupervised learning uses mainly clustering algorithms. Now, I'm not going to dive into the details and specifics of machine learning methods because it's not really the focus of this presentation. Um, and it would take a lot of time to explain all the various methods of machine learning. The third thing on the list is manual verification. Now, content on these social network sites can be analyzed in different ways to determine whether it's true or false and whether the account is a Sybil or a real account. And often it's the job of the users on the social network to determine um, whether the content violates the rules and the terms of privacy of the site or not. And most of these sites will allow you to report users for breaking the terms or rules. And once these users get reported, people will manually look at the reports to determine whether it's justified or not and ban the account. This is one protection against fake accounts. These online social networks also usually identify and authenticate public figures and key brand um, accounts and provide them with verified accounts, which is usually distinguished by a badge, um, which can be used to differentiate between fake and normal accounts. However, this is not possible for every single person to obtain. And lastly, we have prevention approaches. Now, prevention approaches seek to defeat Sybil attacks and other accounts by connecting the identities to resources that the attackers cannot easily obtain. For example, in order to create a new account, they may require a social security number or a passport number. Um, these numbers are not easily able to be obtained in mass quantities. A simpler approach would be CAPTCHAs or other various puzzles that are required when creating an account. And the most recent approach has been to verify the user's identity through text messages to the user's phone. All right, for the first classification of the graph-based schemes, we have Sybil detection. Now, Sybil detection schemes are usually based on the concepts of random walking and mixing time. Um, in the network, you have the honest region, and then you also have the Sybil region. And the honest region of the social graph is usually fast mixing, meaning that the number of random walk movements it takes to get from the initial state to the stationary state is very small. Another property of the graphs is that there are very few attacking edges going from the Sybil users to the honest region, which shows that these social links are very hard to acquire in abundance for the Sybils, which is how you're able to distinguish between the Sybil users from the honest users. For the second classification of the graph-based methods, we have Sybil tolerance. Now, Sybil tolerance seeks to limit the effects of Sybils that are already present in the online social network. In order to do this, they create essentially a credit network where the edges are assigned credit values, um, which the end goal is that it ultimately limits the impact of these attacking edges to the rest of the network. Because as we discussed previously, these Sybils have very limited amounts of edges into the honest region of the graph. And due to the credit network system, only the credit values on the edges, on the attacking edges matter, and the credit values for all the other Sybils connected together um, aren't particularly valuable. Graph-based schemes are great at detecting Sybils, however, they're not without their issues. First of all, it takes massive amounts of space and time to run these algorithms and random walks on the network. And it's definitely a new area of study, um, which needs more research on how exactly mixing time works and other properties of the network graphs come into play. So ideally, your defense system would incorporate not just one scheme, but all four schemes working in tandem. Preventative approaches, as we discussed before, cut down on account creation, which will mean you won't have to walk through as many nodes. Same for machine learning algorithms, and they can filter all the flagged accounts um, into a priority queue, with the top priority queue being more likely to be a Sybil, which makes it easy for manual verification to go through with actual people and flag or lock these accounts. What's next? More research. These graph-based solutions are based off social network properties in order to identify the Sybil users and function. And even today, we're still gaining new understandings of how social networks function and their various properties, which could help aid these graph-based solutions. Another thing is the cost and time and space could definitely be improved for these graph-based solutions, which would help vastly in identifying Sybil users in very large social networks. Thank you all for listening to this presentation, and I hope you learned something new about Sybil attacks and identifying fake users.